All right, so this little one is 1. If you flip it over and it's red, that's -1. When we draw it, we just shade it in. The rectangle stands for x, 1x. If you flip it over, what do you think that means? -x. And the big square, which we're not going to do anything with here today, but I'm showing it to you because it shows up on Delta Math, is x squared. And if you flip it over, it is a -x squared. So what happens with these is if you have a positive x and a negative x, they would do what? If you have a positive of something and a negative of something, they cancel each other out, is the idea of what we're looking at, okay? So let's draw our little key. The small square is 1. If it's red, but not going to draw it in red. I guess you could if you had a red pen. We're just going to shade it in. That's -1. And then the rectangle is x. And if you shade it in, that's -x. And again, the big square was x squared. I'm not going to have you draw any of those, but I just showed it to you because it does show up on Delta Math. But you do have to know these because these tiles show up on the SOL. It's like little pictures of them. So you've got to be able to identify them and draw them. So that's your key. So when it says model each of the expression using tiles, you're just going to draw what that expression is. So the first one, 3x. Well, the rectangle stands for x. You're just going to draw 3 of them. This is like doodling in math class. You're going to draw 3 of the rectangles. Your art doesn't need to be perfect. I'm not grading your art skills. I just need to be able to tell it's a rectangle. Okay. And then it says -2. So what do you think we need to draw for a -2?
-1, right?
So it's going to be like the little square. We have to shade it in. And there's going to have to be 2 of them. So this is your -2. So that's just a representation visually of what 3x - 2 is. Okay, which is different from this. And do you see how one has parentheses and one doesn't? Clear on that? Okay, because you have to be a good noticer. Watch. When you see parentheses, you just cover up the number out front. And that's the thing that you want to draw. X - 2, you just want to draw it 3 times. So when you see parentheses, just cover up the number that's out front, draw that, and then do it that number of times. So an x - 2 would look like this. You have 1 rectangle and 2 of the little squares. That's an x - 2. You then just want 3 of them. So here's another x - 2. And then here's a third x - 2. So again, when you see parentheses, cover up the number out front, draw it, and then just do that number of them. And the idea behind the tiles is then you can see visually what it's going to simplify to. So it says, so what is another way to write this? Well, look at what you have total. How many x's do you have total? 3. So you have 3x and then -6. The way you can get it without the tiles, which is what we're going to do when we flip the paper over, is you take the 3 and distribute it through there. Okay, but we're going to draw it with the tiles first. Then when we flip the paper over, we're going to simplify them without the tiles. It's kind of like taking off the training wheel. All right, so are we all good so far? Okay. So for this one, -2x, what would I draw for a -2x? Just that first part. Or 2 shaded rectangles. Good. So here's your -2x plus 3 parentheses x - 2. So again, when you have parentheses, you cover up the number out front. We're going to draw an x - 2. So a rectangle and then 2 little shaded squares. But then you want 3 of them. So just do 3 of them. And it doesn't need to look perfect. Mine's just like a little scribble. You just need to be able to tell what's a rectangle and what's a square. So when you go to draw the simplified one, what you're going to do is cancel out the positives and negatives. So just watch me point to this. Do you see how we have a negative x and then right here a positive x? So those are going to cancel. You can just x them out. Yay, that's good. You want stuff to go away. All right, and then do you see how we have another one, a negative x and a positive x? So those go away. You can just x them out. So the simplified expression is what's left. So we have one of the rectangles and then 6 of the little shaded in squares. So the simplified one is what's left after you've canceled out. And so then what's the simplified expression? So you're looking at this, we're going to write it as an expression. Yeah, good. 1x minus 6. If you want to put the 1 in front of the x, you can. That's up to you. So we're going to try that one more time drawing it, and then when we flip the paper over, we're going to simplify without drawing the tiles. So for this one, first of all, 5x. So you're going to draw 5 of the rectangles. Now, don't get ahead of me because this one's a little tricky. When you have parentheses, cover up the number out front. Now in x minus 3, don't draw this. I'm going to just show you what it would look like. An x minus 3 would look like this. Do you see what I'm saying? Okay. But we want 2 of them. And do you see how it's negative? You're with me here? That means it's opposite. So instead of a positive x and a negative 3, you're going to want a negative x and a positive 3. And you want 2 of them. When you use the actual tiles, you can just flip them over, but we're not using the actual tiles, we're drawing it. So this is what an x minus 3 would look like. We wanted 2 of them, and we wanted it to be opposite. So it's the opposite of what I drew here. So you can always draw it off to the side and then just do the opposite of that, if that helps you visually. And then the idea is that you want to X stuff out. You want to cancel some things. So we can cancel a little bit, not too much. But what's going to go away when we go to simplify it? Like, do you see any positives and negatives that we can get rid of? Yeah, 2 of them, right? So this one and this one. And then another. It doesn't really matter which one you X out. Perfect. It doesn't make a difference. All right, so the simplified expression is what's left. So we have 3 of the rectangles left and 6 of the squares. And the whole idea, like what we're headed towards, like the goal here is to be able to write the simplified expression. So what does this represent is the whole point of the whole thing. They're all positive, 3x plus 6. So that's what the tiles look like. What we're going to do is flip the paper over and we're going to practice simplifying them without the tiles. So we're not going to draw tiles. We're going to simplify it without them is the goal. So if you liked drawing them, I'm sorry. If you didn't like drawing them, good. We don't have to draw anymore. Yay. But those do show up on the SOL, so you have to know what they mean. So like terms. What is a like term? In your own words, because we're going to write like a definition here, but I know you know what that means. Like, what is a like term or 2 things that are like terms?
The same term, but are different. They're like the same, but like are different.
Well, the number in front of them can be different, but like the variable is the same. So it's the same variable. And I should say as well, and exponent. Because if you have an x and an x squared, those are different. Those are not like terms. So it has to be the same variable with the same exponent. They can have a different number in front of them. That's called a coefficient. That part can be different. but the same variable and exponent. So let's do an example. 5x squared and 7x squared. The x squared part is the same. That's the part that makes them like terms. So what do you do to combine them? You're just going to add or subtract the coefficients, which are the numbers out front. So that's when you're distributing. We're going to get to that in a second. But just when you're combining them, you're just going to add or subtract the numbers that are out front. So just the coefficients. So like, for example, if you were going to add these two together, you would just add the 5 plus 7 and get 12. And the x squared part stays the same. So like this would be 12x squared if you wanted to like put that on there. If you added those together, it would just be 12x squared. It's kind of like you have 5 apples plus 7 apples, you would have 12 apples. They're still apples, they didn't change to oranges or something, like it's still gonna be x squared. So let's try putting our like terms together. I usually just put like squares around the things that are the same. So let's put all the x's together. We have a negative 4x and a plus 7x. So if you put those together, what are you gonna get? Good, 3x. Negative 4 plus 7 will give you 3, or 7 minus 4 equals 3. And then you can put all the numbers together as well. So 6 plus 5, the 11 minus 1 is 10. And that's your answer. So that's how you do that without drawing the tiles. Tiles, yeah, I would agree with you. Well, it's less work for sure. We like less work, okay? Now here, what's going to go together is the 13x and the plus 4x. The minus 7y doesn't have a like term. There's not another y in there, so it doesn't go with anything. So this is going to give us what? So 17x, and then the minus 7y is just there. I don't have a better explanation for that than it's just there. Just leave it there. And then in this one, what's going to go together? Yeah, 5x and 4x. So together would be 9x. Does any of the rest of that have a like term? Why won't they go together? Because it's got a squared in it. And then this one doesn't have an x at all. So it's all just there. You just copy it down. Don't do anything with it. If it doesn't go together, just don't do anything. If there's nothing that can be done, then just do nothing. Now here's where the multiplying comes in, is distributive. That's when you have parentheses. You take whatever number's out front and you multiply it through. And usually, like your teacher probably drew in the little rainbows, you're multiplying it to each of those numbers. So for example, for this one, you would take the 3 and multiply it through there. So just do them one at a time. 3 times 2x would give you 6x. So just 3 times 2 is 6, and then the x is there. And then 3 times negative 4 would be negative 12. So you're just distributing through there. You just have to be really, really careful when there's a negative out front. So for this one, you're distributing not a 3, but a negative 3. So just be careful. Negative signs are the most commonly missed symbol all the way up through AP calculus. Even my advanced students mess up the negatives. It's just like, they're hard, right? So negative 3 times 5x, that would be negative 15x. And then negative 3 times negative 6 would be positive 18 because the negatives cancel. And I like the Chromebooks put away while I'm teaching, but obviously you guys can use Desmos on homework, quizzes, tests, and you can always type into the calculator if you're ever not sure what something equals. Now, sometimes you have to distribute and then put like terms together. So these are going to be 2-step problems. No. So you're going to take this negative 5 and distribute it through there. We've done a few, so let me ask you, what would that give you if you distribute the negative 5 into those parentheses? Negative 5x. And then, good, negatives cancel, so plus 30. And then you've got a plus 2x that's just there. Like, it's just there and you just write it. Now there's another step, because 2 of those will go together. which two are gonna combine? Good, now it's gonna be negative. You have -5 plus 2. So good, -3x, and then the plus 30 is just there. So this is your final answer. Again, if the negatives bother you, you'll always have access to a calculator. I just like the computers put away while I'm teaching. All right, and then this one's a little bit longer, but I believe in you. We're gonna distribute the 5. So what would we get if we distribute a 5? If you answered it already, that's fine, but flip back because I want to make sure your answer's right. So 15x, good, plus 20, awesome. The second part, you're distributing not a 2, a -2. So just be really careful. That would give you -2x and then plus 16, perfect. And then you put the like terms together. So which two are going to go together? Yeah, good. So 15 minus 2 be 13. So 13x. And then the 20 and the 16 go together as well. So that'll be plus 36. Did you get it right? Thumbs up. So this last page we're going to do is writing expressions and equations for real world situations. So here are the steps. Define the variables. A lot of times you use X, but you can also use a letter that makes sense in the problem. Like if you're talking about people, you could use P for people or something. I don't know. You can always pick a letter that makes sense in the problem if that suits you. It doesn't matter, but you have to define the variable. Like P equals people or M equals money or something like that. You write that down first, and then you use your brain and figure out what it's trying to say and write an algebraic expression for it. So number 1, the bill at a restaurant is split evenly between 4 people. So I'm going to let X equal the total bill. So that's like when the waiter or waitress brings you your bill and it says it's $50. That's what the X represents, is how much the bill costs. Now, if you want to take that amount and split it evenly amongst the 4 people, you would take X and do what to it? Divide it by, we're not doing that right now, okay? Go ahead and put that away, please. Can you go ahead and put that away, please? Thanks. So you're going to take X and divide it by 4. And so that's all you're doing. And if you wanted to instead write it this way, that's fine too. Those mean the same thing. If you're like, that's it, yep, you define the variable and then you write the expression that stands for it, okay? So number 2, let's try it again. The total points earned by the Mechanicsville High School volleyball team is 5 more than the total points earned by the Atlee volleyball team. We're gonna need 2 variables for this one because there's 2 things going on. So I'm going to let X equal our points, and I'm going to let Y equal Atlee's points. So you define the variables. And in this case, we needed 2 of them because there was 2 different things going on. And I use X and Y, but again, you could really use whatever letter you want. If you wanted M for MHS and then A for Atlee, like it's up to you. But that's why you define it, is because you're defining it, like you're in control of that. Now, to write the expression, it said we had 5 more points than them. We had 5 more than they had. So how would you write that? There is going to be a plus 5. Well, it would be Y plus 5 because you have to take their points and add 5. And that would equal our points. So if you take their score and add 5 to it, you would get our score because we had 5 more than them. All right, number 3. It costs $10 to get into the parking garage. Answer yourself. And then 2 hours for each, or $2, excuse me, for each hour that you park there. So I'm going to let X equal the number of hours. So X is how long we parked in the garage. And you're going to take your 10 that you have to pay just to get in the door plus,
Wait.
yeah, and I'm gonna write 2x, but I mean, if you wrote x2, I wouldn't mark that wrong. We just usually put the number out front, plus 2x. So it's $10 just to get in, and then plus $2 for every hour that you're there. This one's really similar. I made two like this because it comes up a lot. It's $6 to get into the fair, and then $3 per ride. So I'm gonna let X equal the number of rides I go on. And then what would be an expression to represent what's going on? It's real similar to the parking garage one we just did. Good, 6 plus 3x. So you pay $6 to get in, and then it's $3 per ride you go on. Extension questions, because I believe you could do this. Pretend you're at the fair. You have $20. How many rides can you go on? Think about it. You have $20. It's $6 to get in.
Wait, what?
So you have $20. You have to pay 6 to get in. So already how much are you down to?
14 more.
So you have 14. It's $3 per ride. So how many rides?
Only
can
ride 4.
you can go on 4 rides. Will you have any money left over? And if so, how many will you have? You'll have $2 left over. Good job, guys. Because you'll pay the 6 to get in. Your 4 rides would be 12. That's $18. And so you'll have $2 left over.